So, hey, good morning, everyone. Great to see you here to the second day of the Open Community for Automotive. I have the pleasure to kickstart that today. So, with a great talk about establishing an open source software culture in the automotive industry. And we have here on the stage Kai and Steven, who would like to introduce themselves right now. So, enjoy the talk, and the stage is yours. Thank you.
All right. So welcome, everyone. A little disclaimer, Kai and I have been editing these slides for like weeks, trying to come up with what we actually should be talking about. It's quite challenging, actually, to say the least. You want to introduce yourself first?
Yeah, sure. My name is Kai Hudalla. I have been with Bosch for 25 years now. I'm a software developer at heart. Always have been developing software, however, mostly in a different domain. My most experience is in cloud-based development and enterprise IT. I just joined the automotive domain, I think 1.5 or 2 years ago, making some interesting discoveries in how different this community and domain is from all of what I had experienced before. But still, I have a lot of experience in open source software development. I joined the Eclipse IoT Working Group in 2016 with Bosch I/O back then, and had been developing software for cloud connectivity of IoT devices. And so I'm the one who has the most open source experience here between us. But yeah, Steven, now tell us where you're from.
I'm going to do a little from the past to the future. So some of you might know the predicament that I was in. I formerly was working for General Motors as a technical fellow responsible for the SDV architecture there. And so a lot of the lessons learned, experiences in adopting open source will be from that context. From that experience, I was the founder or leader of the uProtocol, so I'm still project lead for that initiative. And then soon, starting in a couple of weeks, I'll be working for BlackBerry QNX. So really looking forward to that new opportunity.
Okay, so the interesting thing here is that basically I entered this automotive domain having no clue about the automotive domain, but knowing about open source. And you entered the open source domain having all the knowledge in automotive, but no clue about open source, or a little at least. So.
Pretty much.
Okay, so I am therefore talking about the automotive shit. And I do not know much about it, but given that I'm from Bosch, this obviously is one of Bosch's most prominent things that we produce, electronic control units. So these things are in most modern cars, 50 to 100 usually these days, I guess. Is that about right?
Yeah.
And they are basically the first places in vehicles where software was deployed. And not only software for fancy stuff like playing your playlist, but this is really mission-critical stuff. We all bet our lives on it. If these things fail, then the brakes fail, or the electric steering doesn't really work anymore. So these things are really important. And thank you very much.
I can hear myself think.
So these things are really important, and they are therefore will still be a very important part of any vehicle in the future, I guess. Given that they are so mission critical, they need to be usually safety certified if they have a function in a safety context, meaning brakes or steering control, stuff like that. And for that, there are certain regulatory frameworks like the ISO 26262 and other standards that have been created around how to develop the software that is about to go into such devices. These processes are usually very strict and require a certain kind of documentation, a process to follow. You need to provide artifacts that basically prove that you have done the right thing. And in the early days, or as part of this development in the early 2000s, the AUTOSAR consortium created a frame set of runtime environments, specifications, and processes. And this allowed basically the automotive industry to easily implement these things. So the idea there was mostly to use model-driven development and to basically only model what types of signals needed to be processed in what way. And then a code generator would create the code that would then be deployed into the CCCU. So this is not what you, or at least me, considered developing any software. That was basically, we design some networks of signals, then press a button, and then some binary pops out that gets deployed. The idea also was that since these ECUs are basically created, designed, and implemented only on behalf of, or as requested by automotive OEMs, that you, as a tier, as Bosch, for example, simply create and build these things on a custom specification from an OEM. You build it once, you deliver it to the customer, and then you hope that you never need to touch it again. So it has to stay intact and operational for the whole lifetime of the vehicle. Very seldomly only, you will hope that, the tiers at least, hope that they very seldomly need to update these things, because that usually means you need to drive the vehicle into a shop, then they need to attach diagnostic stuff, and then it's a complicated process of updating the software in such an ECU. And it's usually very expensive. Then another thing to keep in mind is these things are very tightly coupled to the hardware that it's implemented on. Within the box, there is a little processor, a microcontroller usually, some RAM, and it is all custom designed and built for the purpose at hand. So this is not standard hardware like a Raspberry Pi or whatever. This is always being custom designed for any purpose. So with that in mind, we go to a classic E2E architecture. This is how the standard E2E architecture of a vehicle has been looking for the last 20 years. Is that about right? Yeah. So you had a head unit, which is mainly consisting of a few switches and connectors and stuff. And then from there, all of the ECUs in the vehicle are connected to that in order to exchange signals. And the signals are transmitted over the CAN bus, which is basically a two-wire bus system, which had been invented, I think, end of the 90s, something like that. And the signals are being transmitted in 8-byte blocks. And the way that the signal is encoded, meaning what is the meaning of the signal in itself, what is the semantics, how is it encoded, which bit means what, that is the so-called CAN matrix, and that is OEM specific. Every OEM does it differently. It's part of designing the E2E architecture. I already mentioned that these things are custom built for each OEM, and they are mostly based on AUTOSAR development tools and runtimes. I also mentioned that shortly, but the impact of that is that this is a very exclusive environment, meaning these tools are very expensive, so a student dropping out of university has never seen any of that before he enters the automotive domain. It's simply not possible to find students who know how to use these tools. And conversely, no student is interested in doing that, because doing that means I am focusing on this small domain, which is nothing that I can add to my resume and makes me employable in any other industry. Nobody else in the world cares about this. And this, in fact, altogether leads to a totally specifically designed hardware-software environment per vehicle. There is no reuse whatsoever. Usually none of these ECUs are being reused for different customers or different models of vehicles. And there is no interoperability due to the fact that all the data exchange is being done based on secrets, if you will. So recently, I think maybe 3 or 4 years ago, there has been talk about, well, why don't we turn the vehicle into a mobile phone, or the other way around? How would it be if we were able to decouple all of the hardware from the functionality, from the software that is being deployed in the vehicle? And we all know that today a vehicle has integration with a smartphone. You can run Spotify, you can read emails, stuff like that. So this is the first step of all of that. The idea always being the same. There is a standard platform, or there is a hardware underneath, and interacting with this hardware from the software should be as standard as possible so that you can achieve an extensible common ecosystem of software components that can run on it. What this usually led to is some hopes that people have for SDVs, and I try to pick out a few of them that I personally believe are more interesting or the most important ones. On top, there is this idea of using a POSIX-based OS, which is, as the little tux indicates, not QNX. I'm sorry, Stephen, but is Linux-based usually. That's at least the idea or hope that people try to achieve. And then you will have a certain kind of hardware abstraction, and in particular abstracting the signals that are available in the vehicle that have so far only been available on a CAN bus. The idea here being that you have a high level abstraction of that, like something like Covisa VSS. Does anybody know Covisa VSS? Okay, don't need to mention it anymore. So this is usually the idea that you have an API where you can get to that data using something like VSS. Then the next thing is a state-of-the-art development model. I touched on it shortly. No student knows how to develop any of that. People know how to implement stuff in Java, in Rust, in C, where you have a compiler, where you have an IDE, where you have libraries that can do stuff. This is what people learn to do. This is how people work today. Then you have stuff like continuous integration. You have repositories. You have Git distributed development. All of that is part of a huge tool chain environment, development environment that modern software developers are used to do, following agile processes, sharing code, reusing existing stuff. That is what they do. And that is also the dream here. Get away from this totally proprietary AutoSAR-based development process to something that normal people use. Is that fair to say? Okay. Then, in the end, you want to have an app ecosystem that you might want to talk about a little.
So now that we had the open source guy talk all about the automotive stuff, we thought an automotive guy should talk about the open source stuff. Mainly because before, previously at General Motors, before working in open source, I had no clue how it all worked. I just saw how good it looked, right? So what's interesting is that this traditional approach that Kai was talking about, there are a lot of problems now that we see, right? And I love this this picture. I probably should have quoted it, but where I stole it off the interweb. But anyway, the idea is that it's true. When I say we're all in the same boat, it's all of the OEMs, the tier ones, as an industry, we're kind of in the same boat. And the real issue is that if you look at successful ecosystems, application ecosystems in particular, if you want to pick on one of those items that was on Kai's list before, you really need an app ecosystem that is available to tens or hundreds of millions of devices. And that traditional OEMs, when they build their app ecosystems, really they're focused for their environment, which might reach up to maybe 1 million vehicles or hundreds of thousands of vehicles. And there are a lot of other app ecosystems that are out there, middlewares. We'll talk about in another presentation the plumbing layer, as we call it. But these other ecosystems that are out there, some of them might be open source, like Android, for example, but they're controlled by, I like to call them monopolies. So what is different from that, from what the automotive industry really needs, is an actual open ecosystem that multiple OEMs, multiple companies are all contributing together. And the only way that you can do that really is with open source. And so this point is one of the things that frustrated me when I was working at GM, actually, is that we were competing with each other even as we were doing this SDV space. So, I think I saw 7, and now I think it's up to 8 different full-stack SDV software solutions. But if we do that, and if we each come up with our own proprietary full-stack solution, we're no better off than we were yesterday. So what we really need to do is all leverage and rally around one solution, or at least core components that we can all share and leverage. And so from that, we're going to now shift to talk actually about, and the point is that only really tier tier 1s and tier 2s benefit from this, right? Because if every OEM wants a different solution, then they're happy to build 7 different solutions for 7 different OEMs. But that doesn't really help the end customer and the OEMs. So I'm going to shift actually to talk about the culture and how you contribute into open source to be successful. And also, at the same time, I'll talk about how and why, because I think the why is very important. And we kind of, we're going back and forth on what these slides should be. And we kind of came up with levels, like when you're in a game and you're leveling up. The reality is that all of us, everyone, consumes open source software, right? And what this means is that you're going to the open source, you're looking at what is there, and you're downloading the open source software. And in order to do this successfully, obviously as a company, you need to have a compliance office. You need to be able to make sure that you're adhering to the licensing of the projects, and you're not using incorrectly GPL or MIT or other projects.
This is actually, I believe this is the step that the traditional automotive industry has the least problem with, establishing more compliance.
Yes. Yeah. And also, what we say about consumption, historically, companies, what we do is we consume the code, but we consume it at the start of the project, and we don't actually do the C in the CI/CD, right? And the key is what I'm telling, in order to be a good level 1 OSS participant, is really continuously integrating and developing as you're building your products. Because if you're not going to get the bug fixes, the changes, and improvements.
And so that is totally different from the build once, never touch again approach,
yes.
right? That
yes,
is
exactly
the opposite. Especially
if you want to be able to update your software continuously to get all the latest features and improvements for your customers. And then finally, to be a good citizen in open source at a level 1, right, in contributing. And we'll get at the very end as to how this resulted in the culture. Don't worry, I promise. But a level 1 at the end is really like, okay, I've consumed something, I've noticed an issue, I'm reporting it back. So sometimes what we used to do at GM was, if there was an open source project, there was an issue, we would report it, right? And then by reporting those issues, hoping that the project people would fix it, at least we're doing the basic, what we call level 1 support.
And this is, however, also already connected to the way that the software is consumed traditionally. I think many automotive players actually have a problem with even providing feedback.
Yes.
Because they are not allowed to do that even. Some of the employees are not accustomed to using GitHub to create an issue, to claim officially, thereby maybe even exposing, hey, we as this manufacturer, we are using this software.
That software, yeah.
They're not even allowed to do that, and this is a cultural problem, or this is a problem that needs to be addressed at the very strategic or fundamental level, I guess.
And so if you've been able to do that basic level 1, and if you can think of not providing the feedback, you're kind of at like level 0, which is what a lot of companies get stuck at. But there are more important levels, and there are benefits at each level. And I'm going to explain the lessons learned that I personally had when I was working at GM, and what GM did as well at that time. And so kind of the next level of OSS consumption is being responsible consumption. And so although you might think before was, I thought you're responsibly consuming it, but really the reality is responsibly consuming it is providing more than just feedback to the open source project that you're consuming. And I want to say that we leveled up to this point in 2019 when GM signed the contributor license agreement with Google. It took me 2.5 years of convincing our leadership, but we finally did that, and that allowed us to contribute back. So what that means is that you're also not just consuming the code, but you're actually actively contributing code back. And so by that, what I mean is that, what the fork are you doing? The reality is one of the biggest things culturally I had to do with the company is to tell people, do not fork the code. taking the code into your project and consuming it responsibly means anything that I do to improve the code pushes back upstream. As soon as you fork it, and why would you not fork, is because you start deviating. Every time you pull down versions, you have to now patch and maintain, and you're not responsibly providing back to the community. And now you're having to maintain your version and pulling in the open source. It's more work and so on.
Before you go on, I would like to comment on that. This is actually a very, very big step for most organizations compared to just consuming the software and adhering to compliance rules. Yeah. Because now every individual contributor needs to know what he is doing. You would assume that is what they do anyways, but at least from my experience from Bosch, that is not always the case, at least not in the beginning. So people need to get educated about open source licenses, about under what circumstances can you actually use this software or make this change, or you need to have something in place that makes sure that you're not giving away internal patents that your employer has. You need to think about the impact or the impression that you make in the community when you contribute to that code using official email addresses from your employer, if that is what you choose to do. So this requires even more organizational and cultural change within your organization, but this is totally necessary in order to be successful, from my point of view.
In order to level up. Yeah. And like I said, there are great benefits to the company and to the individuals. And once we get to the next level, I'll show about how those benefits from the culture starts coming back to the organization as well. And what's interesting is this is related also, we put this up there before it was mentioned in the keynote yesterday. The reality is that you have to assemble software to build a product. You're going to pay a company to build closed source software, or you can pay to contribute to an open source project. And paying is not necessarily about your money. It's always the time, talent, or treasure, right? So the idea is that investing in your time in order to be able to support the project, investing in your talent, meaning you're putting your resources in to work at this open source project. You're taking on a responsibility that I am consuming this code. It is important as an organization. So what I need to do is I need to invest in that, but with the resources and possibly paying.
And I think that is the most important part. As it was mentioned yesterday in the keynote, if you identify any of these open source components as technically or strategically important for your product, there is no way around getting involved in that technology, because you definitely have to be able to get into action if anything is happening. If there is a bug that is not fixed by anybody, you need to be able to fix it, or you need to know somebody that you can pay for fixing it. And again, there is simply no way around getting involved. That is, I think, the key message, at least from my point of view.
So in the journey that I personally had while I was working at General Motors and the journey that we did with the Eclipse project and with open source in general, is we saw the need to kind of level up to the next level, which is what I hear a lot of other OEMs and other companies interested in doing, but I want you to understand what that means. So we talked about the previous levels, and if you really want to be at the next level, there's even more that is required, but also greater benefits that come of it. So for example, if you're going to want to go to the next level of being actively driving in the community, we've already talked about you put your money where your mouth is, you actually have your people and who are working in the code base, you've worked out the logistics, but in order to drive the community, you really do need to have a business model as to a means to the end. You have to know what your objectives are in order to actively engage in the community. And this is to ensure that, if you're going to do something like successful open source projects companies that do open source projects, they have business models where a portion is free, and then for support or maintenance or additional features, you pay for those, or subscription or other things. You need to have, as a company, a business model around it. It could be simply as, I absolutely need this product, this piece of code in order for my vehicles to function, and as a result, I'm investing to ensure that this project is successful and with people, time, resources. Did I miss anything?
I would simply add to that, if you have a business model, and then you can derive your open source strategy from that, but it's never the other way around. I've seen this so many times within organizations. They are so enthusiastic about open sourcing stuff because it's total fun for developers. They love that. Then we open source something, and then we hope that we find a good use case or business model around that. But it should actually be the other way around. You need to be clear about what are my objectives, where do I get the money from, what do I earn the money with, and then engaging in open source or using open source should just be a means to that end, helping reaching that goal.
So that actually is a good segue to the next thing from Frozen about let it go. Because one thing that's very, and I don't mean to pick on anybody or any projects, but the reality is that you might have a good piece of software that solves a purpose and you want to open source it because you want to drive the community. But the way for the community to be successful is for all of us to work together. And so if there's already a project out there that is very similar to what you have done or what you would like to do or what you want to open source, it is far more beneficial for the overall community if you just let it go of what you had and work towards the supporting the existing software that's there. And I'm not saying that because I want everybody to drop their communication middleware and use uProtocol. I would love that. But the point is we don't need yet another orchestrator. And I'm sorry to pick on but the point is that we have so many great open source projects that are there. Now is the time we work together to improve them, and we add the features and functions to them, so then we can start adding them back into our...
One of the other reasons for that, and I totally agree with what you say, is that making a successful open source project is usually mostly about creating the community around it. And there is only ever the community that you build. So if you start an open source project, then dropping the code or the initial code is the simplest thing of all. But then the real work starts, building a community, talking about it, finding allies, finding people who are interested in it, convincing others to use it, to engage in it. This is really, really hard work. This is going to conferences, establishing direct connections, talking to your sales organization, educating them about them, to mention this in their pitches. This is the hard work, and it's always easier to join an existing community that is already there, that is basically functioning, than building your own. Believe me, I know what I'm talking about.
And that actually leads to the last point of the reality is that it's a marathon, not a sprint. We all know it takes a long time to build a community, to also build software. And the reality is that it takes time. I mean, we had a version of uProtocol that we put into production into our current vehicles, and then we open sourced it and realized we have a lot to learn. And working with others and a lot of discussions and so on, the protocol evolved into something that was far better than we ever first proposed. We had an ambition, we had a goal, we had an idea. We didn't have all of the technical knowledge that we got by working with, in uProtocol there was 5 different other companies that were working with General Motors on providing code and still contribute. There are committers in that project that are non-GM employees. There's quite a lot of them. And so the point is that it's a marathon. We have to work together and realize that it's a constant effort in working in that community, and it's not something you dump and run. Projects that dump and run usually don't go anywhere. And
what struck me when you said that was, in comparison to this build once, never touch again, this is also a realization of, I think, hardware manufacturers, that software is never done. So this is a continuous effort. This will never end. You just don't build it until it's done or ready. then you extend it, improve it, get more feedback. So this always requires more and more investment and effort continuously once it is successful in order to remain successful and usable.
So what was interesting about our presentation is that we kind of started with explaining what the open source development culture was. But then we were talking about this progression going from level 1, level 2, level 3, and then as we were doing level 3, myself and my fellow colleagues at General Motors and working with the community, I actually only then learned what the culture was. And then from that, all of the incredible benefits. And so actually, it's a great way to end talking about what this culture really does do for a company and an organization. And the reality is that in a closed source, you're strictly following various processes that are set out by long-standing requirements documentation. But in an open source project, it's very decentralized. I mean, you also have to have that let it go mentality. Historically, there is somebody who's writing a specification, they're the ultimate authority, and then they're the ones who decide what goes in. But that's not how it works in an open source project. If I propose something and Kai says it's shit, then he has a reason why he says it's crap, and we discuss it, and we go through it, and we find out what's the best way about it, and we change the specifications for the better, because the idea is that it's always for the community and for the better.
And this happened a lot, right?
A lot.
Yeah.
And so it's also very different in that that goes to the next point about closed source software development. What's that association about your code matches your hierarchy structure? What is the...
Yeah, there's a law for that. What is it called? Conway's Law.
Conway's Law.
Exactly. Yeah.
But that does not happen at all in the open source software. The way that the code is structured is the best way that the code could be structured. And if it happens to not be structured that way, then we change it, and we improve it, and we change the structure. We rename the projects so many times, and we reorganize the projects quite a few times before we finalized what the architecture is, what the designs are, and so on. And this is what I want to say is I want to make clear. Closed source and software that's being developed by OEMs doesn't mean that it doesn't have quality, right? So the point I'm saying is that closed source software development is really primarily focused on I have a set of requirements and I have an objective and I have to meet these deadlines. But open source is like, I didn't get Kai's review for my change. I'm not going to create a release and send it out. I'm going to wait for the review process to finish. I'm going to wait for the reviewers to provide the appropriate feedback. We're going to make sure that the code has the quality, it has all of the checks, the GitHub workflow actions, and so on, before we do it. And if it means that we missed something, then we will do a release that's missing that feature or pull request, or we will postpone it until we have it. So there's a stronger focus on quality and, I don't know, I've heard shift north, shift left, shift whatever, but the point being is that rather than waiting until it gets into a vehicle and it is tested by vehicle validation team, and the development team has already gone off and worked on something else because it was 8 months prior. The focus is, if you're checking in code, it has passed the 10 or 15 different workflows and peer reviews and so on. Actually, there's almost I feel a little fear in actually marking in a pull request, looks good to me, the LG TM.
LG,
So, I want to find something, which is very hard in his pull request, by the way. But still, there's that. And another point is that, and this is where the community is important, customers drive in closed source all of the requirements, right? But in an open source project where there's a community, all of the contributors drive the direction. So if you feel that a piece of code is important to your organization, right? And I had this conversation with people who are not contributing to uProtocol, and they were saying that, no, it needs to do this, that. And I'm like, well, file an issue, voice your concerns, review the code, because the contributors are the ones that drive the direction of the project. And in closing, what's very interesting is that the culture, right? Closed source is a lot of culture of ownership. So those who are familiar with ownership versus stewardship, right? The reality is that, the closed source and the culture of ownership is that it's mine. If it's taken away from me, there's resentment. It belongs to me. I'm delivering and I'm responsible. But when it's a stewardship, it's more of a working together as a community. The code doesn't belong to me. And that's what I tell all the developers all the time that we're working on this team. You don't own the code. GM doesn't own the code. Nobody owns the code. The community owns it. So when it's a culture of stewardship, it just naturally comes out a sense of pride, a sense of enjoyment. And actually what was incredible from this is that this is one of the things I learned, and it gives me goosebumps when I think about it too, is that developers were coming to me saying, please, I want to work on this project. Even though the circumstances changed and some of the folks are no longer working on the project and the contributors have changed, they come to me afterwards saying, thank you for being able to work on this. Because in my job reviews, I can point to pull requests and they can see all the code that I've done. Not only that, they felt a sense of belonging, right? They feel a sense of belonging to something greater than they are. Closed source and ownership mentality doesn't do that. So what was very interesting is that the more of the development team grew working on this, the more that culture spread. And it's kind of like a virus for the better, in that it kind of made people happier. To the point where some of the contributors, I had to tell them, guys, it's whatever, go home, you have a family. I'm very happy that you want to work on this project. I'm grateful. But please, disconnect. I never thought I'd have to say that to people before. So the culture of working in open source, and really the more you level up, the more you get that culture of stewardship, of belonging, of gratitude, it brings out this thing in developers' pride and joy.
One personal note on that. Personally, I have been involved in open source for 8 years now. This is the best time of my development career. And what I love most about it is that you get in touch with people outside of your bubble.
Yes.
Outside of your corporate bubble, where everybody thinks we are the smartest, the best, the greatest. No, that is not true. The reality is out there. And that is what open source does for developers. They let them connect with others, and that is so rewarding. At least that is my personal feeling.
I can't agree more. Also, it's a sense of realizing that, you're not the one who knows everything, right? Like if you're an automotive tech fellow who you think you're super smart, and you meet someone that's 10 times smarter than you who can teach you many different things, right? So those kind of situations are just amazing to be able to learn from other people. But not only that, you can learn in an open environment. I can have a conversation with someone at Volvo or someone at BMW, and we can share ideas all for the greater good of that project and that initiative, which at the end of the day is for all of us to ship cars. A little plug for the uProtocol, but the reality is that everybody needs some of these different components, and so if we're all working on it, it'll be good. So anyway, lost my train of thought. But I just wanted to end with this quote, because I think it's relatively important, in that we all have this sense of knowing that it is the right thing to do. And we all agree it is hard, right? And the reality is that the right thing and the hard things are usually always the same. And come to our talk about uProtocol later this afternoon.
And now, rip it apart.
Yes. So thank you. Oh, we were over.
I don't know what it means.
Wow, thank you so much for your great insights into your work and to the open source work also within an automotive, in two automotive companies. Really impressive from my point of view. Do you have any questions?
Good morning, and thank you very much for a very inspiring speech. So I agreed with almost everything, but I was thinking about, I absolutely agree that the code is never done, but it's not a problem at the moment that the SDVs are shooting out of the automotive industry, right? There is a lot of delays going on. So how do you assure these ways of working while at the same time finding out when is the deadline? When is the code good enough? How do you make sure that you don't work too long on perfecting the things? Because in the end, we need to get the code into the vehicles, because otherwise it's been fun, it's been great, we've learned a lot, we probably contributed for the future, but we don't contribute for our business objectives, as you were referring to. So how do you ensure to get the code good enough and make it available in production?
And that's up to the community to decide what is good enough or done. And so if you're somebody who wants to consume it, you need to speak up and say what is missing or what is done and contribute that missing components. You need to set the checks and balances in there that as a community you agree in. And in the uProtocol case, we have weekly meetings where we get together, we talk about, we have very detailed roadmaps and plans. Sometimes they get delayed for one reason or another, but we all have a sense of knowing that what is our objectives. So you need to have clear objectives, and as project leaders, that's kind of one of the roles that a project leader does, is to make sure that there is a plan around the project.
However, we mostly moderate that process, I would say.
Yeah.
In fact, what you point out is very, very true, but it also pays into the argument we made earlier, I guess. If you want things to happen in open source, you need to engage.
Yes.
You cannot simply say, hey guys, I would like to use your software, but it's missing that, and that, so come back in 3 years. I mean, you can do that, but you will not be able to use the software. And if you're really serious about using open source, then you need to get engaged and help implementing it. That's my take on it, I mean.
Thank you.
Okay, thank you for emphasizing the social aspects, the culture. It's not a technical problem, no, it's not. So AutoSAR is very much about CI/CD. V-model was the first model, the process model, which was certified to be agile 25 years back. So it's not a problem. If you go one slide back, so talk about culture, strictly defined process, e.g. ASPICE. That's your interpretation of ASPICE, so that's cultural. You can look at ASPICE, for example, as a guide to define products so that the person which has to work on a product knows what to expect. So you can look at it as a strictly defined process as a jail, or you can look at it as a help. So it's all about culture, yeah.
I think we did not try to say the one is good, the other is bad. It's just pointing out that mostly within open source, for example, there is no real strict defined process, or it can be an arbitrary process defined by the community themselves.
So
that's all.
In automotive, the OEM alone is about 5,000 engineers working together. Taking the first tires, we have 20,000 people more going down all the hierarchy.
Is there a question?
That's a hierarchy. Then we are talking about 40, 50,000 people. And the people should get products as expected.
Is there a question involved?
No,
as well?
that's was more a remark on it. Okay, so.
And yeah, thanks again as well for the talk. So I'm constantly coming back towards that at the end, because you made as well the statement no forking at the end. But how do you see it? Complex topic. OSS and functional safety, because at the end, for the majority of the software that we'll develop for the car, you'll need to have a safety argument and the reliability. So Do you like to comment on that briefly?
I think I did not understand the question.
Well, it's honestly in every open source talk or every open source software, there's always a question about functional safety. And it's one of those things where I don't know how to answer that question, right? So we develop software to meet a purpose, and if there are requirements that are needed in order to add additional bits of verification or validation or max security or so on, we go in there and we add it. If it's a communication protocol, if it's a... So it's, I mean, no matter what you develop in open source or you develop in closed source, if you have a requirement that says you must do this or must be this size or that size, you know, you just code it to do it. So I don't know how it changes in what I'm saying about the culture is it's a different way of approaching how you develop your software in open source versus in closed source. But that has no change to functional safety requirements. You can create functionally safety software in open source.
So I think I agree with that there is a challenge when you, for example, want to build a system with safety requirements that includes dozens or hundreds of open source components, in particular in modern build systems like in Rust. You transitively pull in more and more dependencies, and making sure that all of these meet the requirements in order to be able to get it certified is challenging. I would totally agree to that. But that is not what we wanted to talk about. I have a personal opinion on that, but that would probably be a different talk. And I guess there will be more different additional talks about that.
We're not saying that the entire vehicle will be 100% open source software. I mean, there's totally an understanding that it's a combination of closed source and open source. Also because you need to commercially make money off of selling this software and these products as well. So there will always be a blend of open and closed source. We're just trying to advocate for more of the commodity items that people should just take for granted should be open source. Like what we did for some of the fundamental things that we don't even think of anymore, that are all open source.
And also, guess this is what the AutoSAR ecosystem has been addressing very, very successfully throughout the last 20 years. So there is always and will still be reason for AutoSAR components in the SDV. There is no doubt about that from my point of view.
Yep. So thank you.
So thank you so much. A big applause to Stephen and Kai. So then I have the honor to present you the next talk. So it's about redefining automotive connectivity with Eclipse Zenoh and the setup platform. So I'd like to welcome here Fani Gangula from Zetascale on stage. So Fani is a senior solutions architect at Zetascale with over a decade of experience in communication technologies. Zetascale is doing a great work, doing funny things, great things with communication protocols. And therefore, I'm really curious what you want to tell us today, and the stage is yours. Thank you so much.